Welcome to Chapter 6, 6.1, Operations on Functions. Today we're going to find the sum, the difference, the product, and the quotient of functions. And then we're also going to compose functions. Okay, so today is all about, this lesson is actually a very important lesson. And for those of you who are interested, you will most likely see this a question from this lesson on a standardized test such as an SAT or a PSAT, because it's an important lesson in which we take two equations, two different functions, and then we combine them together into one. We compose them together. Okay, so we take one function and insert it into another. Okay, so let's get right into it. First of all, we need to have some ground rules. So with addition of functions, okay, now you got to pay attention to a couple of things here. We're going to pay attention to some new notation. May not be that new, but hopefully you have seen this before. If you see something like f plus g of x, that's how you would pronounce that. It's saying take the f function and add it to the g function. Okay, so in the example, the f function is 2x, and the g function is negative x plus 5. They're going to add the two together. Okay, so 2x plus negative x plus 5. Notice they use parentheses there. They added them together, and they got x plus 5. Okay, with subtraction, same deal. You can subtract the two functions from each other. You just make sure you use parentheses. Okay, so that example best demonstrates that, where we take one function, subtract the other. And then multiplication, where we take one function and then multiply it by the other. Okay. And then the final thing here is we can divide two functions. Take one function f over g of x is like taking the f function, dividing it by the g function, evaluated it at x. So don't try to put any of these f and g's inside your answer, okay? These are just telling you what to do with those two specific functions. And often we do use the f and g notation for different functions. Okay, so let's look at one. For 1a, we have f plus g of x. Okay, so here's the f function, here's the g function. They want us to add the two together. So I'm going to take the f function, x squared plus 5x minus 2, and I'm going to add it to 3x minus 2. I use parentheses just as a habit. Okay, with addition, it's not that important. With subtraction, it is. Okay, all we're doing here is combining terms, so there's no other x squared term. Okay, so that's done. But then we have 5x and 3x. Those are like terms we can combine to get 8x. And then negative 2 minus 2 would be negative 4. Okay, so there's our answer to 1a. Go ahead and try 1b out. Remember that order is important. We're going to take the f function, x squared plus 5x minus 2. And now it becomes very important that we use parentheses, minus 3x minus 2. Okay, so when I do this, I still get x squared here. And then 5x minus 3x is 2x. And then negative 2 minus negative 2 is negative 2 plus 2, which is just 0, so I am done. Moving right along, for division, it says under division, the domain of the new function is restricted by excluded values that cause the denominator to equal 0. Yeah, that's because, if you take like the number 3 and divide by 0 in your calculator, you're probably going to get some kind of error. Okay, whenever we divide by 0, we know that thing is undefined. Okay, so the same is true here. If I have something like, I don't know, what if I had like 3 over x plus 1? The one solution that would not work in there would be a negative 1, because if I plugged a negative 1 in there, I would get a 0, 3 over 0. Okay, so I have to restrict the domain. I cannot allow a negative 1 into that particular problem. Okay. It says this is not in your notes, but it's important to understand. You can graph the sum and difference functions by graphing each function involved separately, then adding their corresponding functional values. If you examine the graph of f of x and g of x, and their sum and difference, okay, this is just saying that if you find f plus g, okay, notice that f plus g of x is taking, if you study this graph here, you have the f function, which is this dotted line here. Okay, then you have the g function, which is just, it appears to just be y equals x, okay? If you add that together, you're essentially, since the slope of that thing is 1, just 1x, you're just really shifting the whole thing, the whole function, back one space. So notice the f plus g of x just shifts on the x-axis one space to the left. All right, so for example 2, given that f of x equals x squared minus 7x plus 2 and g of x equals x plus 4, find the function. So let's multiply these out. This is saying multiply the f function by the g function. Okay, now this is very different than finding f of g, fog. Okay, so I know it looks like that, but we're going to do that soon. This is multiplication, so it's just taking the two and multiplying them together. So we have x squared minus 7x plus 2 multiplied by x plus 4. We're going to FOIL it out. Okay, so I'm just going to go this way to FOIL it out. So I get x cubed minus 7x squared plus 2x, and then I'm going to go ahead and do the same thing with the 4. So plus 4x squared minus 28x plus 8, just distributing the 4 out there. Okay, now I'm going to combine like terms. So there's only one x cubed term. So for that one, I'm going to have x cubed, and then that's gone. Negative 7x squared plus 4x squared gives me negative 3x squared. And then those are gone. 2 minus 28 is minus 26x. Those are gone, and then plus 8. Okay, so that's that one. For 2b, I'm going to take the f function, x squared minus 7x plus 2, and I'm going to divide it by the g function, x plus 4. Okay, so for this one, technically, I could try to factor this, but it doesn't look like it does factor very nicely, so I'm going to say that that thing is prime. So since there's not a common factor between the two, I can leave it just like this, but then I have to say that x cannot equal negative 4. Because if I plug a negative 4 in here, it makes the denominator go to 0. Okay, so that has to be included in your answer for full credit. Now let's move along to composition of functions, now that we're comfortable with those rules. The composition of functions is now we're going to take a whole function and we're going to insert it into another function. So notice, what this is saying is if you see something like fog, we call it fog, fog and goth, where we take the f function and compose it into the g function. I want you to notice something here. When you see this type of notation, what it means is we're taking the g function, this is the thing that you need to take away from this, and we're putting it into the f function. Okay, so we're going to evaluate f, but we're going to evaluate it at g of x. Okay, so take the g function and plug it into f. Always take the second piece, plug it into the first. So, all right. There's there's a special case. A composition of functions may not exist if it's defined only if the range of g of x is a subset of the domain of f and vice versa. So sometimes we cannot compose things if the domains don't match up with the two things, right? So I'll show you what that looks like because that's going to be confusing until you see an example of that. All right, so here we go, guys. The first thing they're going to have you do is they're going to have you look at a bunch of points. Okay, so here's the points in the f function, here's the points in the g function. What you have to think about is if you're finding fog, okay, fog, is we're going to take the g function, plug the x value in. So notice if we take the g function evaluated at 8, we get a 15 out. Okay, so we're going to take that answer now and plug it into the f function. So if you look over here, the f function has an x value of 15, and the solution to that is 11. So the fog solution here for the first one is going to be 11. Okay, then for the second one, notice we take g of 5. So I'm going to refer to this chart now. So g of 5, we get if we plug in a 5 to the g function, which they've already done for us. They already did the math for us, which is nice. They get the y value 1 out. Then we take that that y value of 1, plug it into the f function, and we get an 8 out. Okay, so that's where 8 comes from. All right, so then notice the final answer for these is always going to be coordinates, right? So when I plug in an 8 for f, or sorry, to g and plug it back into f, I get an 11 out. When I plug a 5 in, I get an 8 out. So notice 8, 11 is one of my solutions, 5, 8 is one of my solutions. If I plug a 10 into g, I get a 14 out. I plug that in to the f function, I get a 9 out. So 10, 9 is one of my answers. And then for the final one here, if I plug a 9 in to the g function, I get a 0 out. Take that 0 and plug it into the f function, I get a 13 out. So 9, 13 is my final. Okay, then it says, let's try to see if g of f works. All right, so for g of f, what I got to do is I got to go the other direction, right? So let's see if the other direction works. So first of all, what I'm going to do is I'm going to take my f function and look at the first one. If I plug a 1 in, I get an 8 out. Okay, is there an 8 in the g function? Yes, there is. So 15 is the solution. So 1, 15 works. All right. If I plug a 0 in to the f function, I get a 13 out. But look at this. There's no 13 in my x values of the g function. So that one is undefined. Notice they say undefined. Okay, if I plug a 15 in and I get 11 out, there's no 11 here in my x's, so that's also undefined. But if I plug a 14 in, I get a 9 out, and then boom, there's a 9, which is 0. So 14, 0 works. Okay, so g of f only has these 2 points because the other 2 are undefined. Okay, so just wanted to show you that one. Now we're going to do this one. So for example 3, make sure you're doing this in your notes. It says to find f of g and then g of f and see if they exist. State the domain and the range. Okay, so if I'm doing f of g, I'm going to start with the g function. Okay, so if I plug a 4 in, okay, if I plug a 4 into the g function, I get a 3 out. Then I'm going to look for that 3 in the f function. Boom. The x values of the f function, right? Okay, so I got there's my 3 there, it matches up, and then it evaluates out to -2. That's the y value. Okay, so 4, -2 is one point that works. Then I'll go to the next one. If I plug a 2 in, so 2, I get a -1 out. Boom, plug that -1 into the f function, I get a -5 out. All right, and then for the next one, I plug a 9 in, I get 4 out. Take that 4, plug it in, I get a 7 out. So 9, 7. And then my final one here, if I plug a 3 in, I get a 10. Plug the 10 back into f, I get an 8. So 3, 8. Okay, so there's my domain would be all the x values, 4, 2, 9, and 3, and my range would be all the y's, -2, -5, 7, and 8. Okay, so make sure you just identify your domain and ranges when you're doing that. And then for g of f, let's try it the other way, and let's see what happens. So we're going to start with the f part of the function, and then plug it back into the g. Okay, so for f, plug a 3 in, I get a -2 out, but there's no -2 in my x values on g, so that one is undefined. Plug a -1 in, I get a -5 out. There's no -5s. That's undefined. Plug a 4 in, I get a 7 out. Are there any 7s here? That's undefined. Plug a 10 in, I get an 8 out. Are there any 8s in the x values? No, there are not. So the g of f function is undefined. Nothing works when I try to plug the f function in for g. There's not a solution that works. Okay, so that's how you do example 3A. For 3B, they want you to find Fogg and Goff now of a function. Now, this is the question that they like to throw at you on a an SAT type deal, so pay close attention here. Hopefully the lesson has made sense thus far. If it hasn't, hopefully this pulls it all together. Okay, so what this means here, if I say find fog, it means take the g function, plug it into the f function for x. Anywhere there's an x in the f function, I'm going to plug in the g function. Okay, so here's my f function. I'm going to start with, something squared plus 2. That's usually how I set this up. I replace the x's with these parentheses. What do I plug in? I plug in the g, x minus 6. Okay, so when I do this, I think they would want us to simplify this. So x minus 6 squared, remember, is not x squared minus 36. Please do not do that. We're going to FOIL this out. We get x squared minus 6x minus 6x again, so that's minus 12x plus 36 plus 2. So the final composition here would be x squared minus 12x plus 38. Okay, so we found f of g. That's the f of g function. Okay, so the domain for this thing is a quadratic, right? So the domain for this would be all reals. But what about the range? What would the range be of this thing? Okay, so to find the range of this thing, the easiest thing to do, since this is a quadratic, so there's a couple things you could do. You could plug this into Desmos or into a graphing calculator and see where the vertex is. I'm not going to take the time to do that here. But you could also find out where the vertex is by taking negative b over 2a, plugging that solution back in to see where the minimum point happens. And it turns out that in this case, it happens at 2. So the range would be all the y values where y is greater than or equal to 2. Okay, so that's how you would find the range there. Now let's do g of f. Okay, so now we're taking the f function, plugging it in for g. Okay, well, g is just something minus 6. That something is the f function, x squared plus 2. Okay, so for this one, we just get x squared. You get 2 minus 6, you get minus 4. So there's my g of f function. The domain for this thing, since this is quadratic, is all reals. The range here is going to be, well, this one's easy, because what this graph looks like is it looks like the y squared graph shifted down by 4. So now we're down here. So it's the y values where y is greater than or equal to negative 4. And we're done. That's how you evaluate those composition functions. The final thing here is a real world problem, which I think I'll do together with you guys in class. I just want you guys to have the skill for now, and I'll get you guys the homework